Good morning, dear students. My name is Farhan Mazher, and the subject we are studying today is Cambridge O Levels Mathematics Syllabus D. We call it D Maths 4024. Today we are working on the syllabus, and the topic on which we are going to work today, that is the addition of the vectors. There are two methods of the addition of the vector, that is triangular law of the vector addition and the parallelogram law of the vector addition. We will also talk about the zero vectors. We will also learn how the vector addition subtraction is done, the triangular law of vector subtraction, and we will also do the addition and subtraction of the column vectors. For this purpose, we are going to attempt exercise 7B from the book D4. The name of the book is New Syllabus Mathematics, 7th edition. So let's start today's exercise. Okay, so here we go. This is the D4, and so let's go to the exercise. So the question number one of the exercise 7B. This is the book published by the Shingley printers. So the chapter here of the vectors is chapter number 5, but the book which in Pakistan we are using is that Oxford University Press, published by the Oxford University Press, and there the chapter is 7. So that's why I say 7B exercise. Okay, so here you have to add up two column vectors. This upper portion in the column vector is called X and the lower portion is called Y. So when you add two column vectors, you add the X with the X and you add Y with the Y. So when you will add it, it will be 2 plus 7, it will be 9, and 4 plus 5, that will be also 9. Okay, in the B part, 3 will be added with the minus 4, you will get minus 1. Minus 5 will be added with the 1, you will get minus 4. So here on your screen, you can see that 3 minus 4 will be minus 1, minus 5 plus 1 will be minus 4. Then the C part, here we have three column vectors, and we will add all of them. All the x's will be added with each other, all the y's will be added with each other. So minus 9 plus 0, minus 3. So it will be minus 12 upstairs, and downstairs it will be minus 2, minus 8, it will be minus 10, minus 10 plus 7, it will be minus 3. So it will be minus 12 and minus 3. That was the question number one. Question number two, he says if A is 4, 3, B is minus 7, 2, C is 1, minus 5. So determine whether A plus B is equals to B plus A. Okay, so first of all, I will try to find out what is the value of the A plus B. So A is 4, 3, and the B is minus 7, 2. So X will be added with the X. So you will have minus 3, and 3 will be added with the 2. It will be minus 5. It will be 5. So let me say this is the first. Then I will find out the value of the B plus A. And the B plus A will be minus 7, 2 plus 4, 3. So minus 7 plus 4, it will be minus 3. And 2 plus 3, it will be 5. So now if you look at both the results are same. So it means that the A plus B and the B plus A, they are the same thing. Okay. So this is how this is done. That was the question number 2, part A. Question number 2, part B, he says find A plus B in the brackets plus C is equals to A plus brackets B plus C. Okay. So we will first of all find A plus B in the bracket and then plus C. So I will put the values there. So 4, 3 plus minus 7, 2. I will put a bracket around them and then plus the value of the C, that is 1 minus 5. So it will be minus 3 and 5. And here you have 1 and minus 5. So you will have minus 2 and 0. So this is the value of the A plus B in the bracket plus the C minus 2, 0. Okay, now I will find the other value, that was A plus bracket B plus C bracket close. So it will be 4, 3 plus, and the bracket you will have minus 7, 2 plus 1 minus 5 in the bracket. So first of all, I will solve these. Minus 7 plus 1, it will be minus 6. 2 plus minus 5, it will be minus 3. So 4 minus 6, it will be minus 2. 3 minus 3, it will be 0. So if you look at the results, if you look at the result of both, so the result from the 1 and the 2, because and the answers are same, so we can say that both the sides are equal to each other. So this is how you will do the question number 2 and its B part. Okay, question number 2, question number 3. Here a diagram is given. He says the diagram shows a quadrilateral PLMN. PLMN, and he says simplify. You see, here are the vectors and we have to add them, LM plus MN. So when you add the vectors, it is important that where the first vector ends, from there the second vector should start. And if this is the case, then the resultant will be the first letter of the first vector and the last letter of the last vector. So for example, here LM, at the M it ends and the next one starts with the M. So it will be LM plus MN, it will be LN. So here you can see I have shown it, and LM plus MN will be equals to LN. Okay, the next one is PN plus LP. Now here is a problem. It ends at N, but it starts with the L, so they cannot be added. But if you put this LP first, then it will become easy. Okay, so Pn plus Lp, first of all I will write the Lp first and then the Pn. Now you can see it is in the good shape, because you know the Lp, it ends at P and this vector starts from the P. So now they are good to be added. So Lp plus Pn will be Ln. Okay, so next one is, he says Ln plus Nm plus Mp. Okay, so Ln plus Nm, it will be Lm, and then you have plus Mp. So Lm plus Mp, it will be Lp. So simple, straightforward question number 3. Okay, so we are going to the next question. The next question is question number 4. Here we have the column vectors, and they want us to add them. So simplify the following. Okay, so this is the first question. So, okay, so 12 and minus 6 plus minus 12, 6. So x will be added in the x, the y will be added in the y. 12 minus 12 is 0, minus 6 plus 6 is 0. So this is the A part, and the B part is 5 and 7 and minus 5 and minus 7. Okay, so 5 plus minus 5, it will be 5 minus 5, that will be 0. 7 minus 7, it will be 0. So this is called the 0 vector. And then we have x plus minus x and y minus y. So it will be x minus x, that will be 0, y minus y, that will be also 0. So this is how you will do question number 4. It's C part. Okay, so we are going to the next question. He says copy and complete the following. So we have to fill these blanks here. So what is added into the 9? So the answer is 0. It will be minus 9. What is added into minus 1? So the answer is 0. It will be plus 1. So let me show you. So the question number 5, A part, is showing up on your screen. You see I have filled the blanks. Okay, here what should be added in the minus 3? That the answer is 0. This means 0 vector, which means 0, 0. What should be added in the 7? So you get 0. It will be minus 7. So let me show you the B part. Okay, so on your screen, the B part is showing up. Hopefully you understand how I have done the fillings. Acha, fill in the blanks. So C part is what should be added in the minus Q so that the answer is 0. It will be plus Q. What should be added in the P so that the answer is 0? It will be minus P. So let me show you question number 5. C part is showing up on your screen. You can see how I have filled those blanks. Okay, so now we are going to the next question. The next question is question number 6. He says simplify the following: A, B plus B, A. Okay, so you go from A to B, from B to A. So your starting point and end point are the same points. So your resultant vector will be a 0 vectors. I have bolded it. Okay, you bold it. Okay, so the next one is PQ plus QR plus RP. Okay, so PQ plus QR, that will be PR. When PR plus RP, your starting point and the end point is the same. So your resultant will be 0 vector. Okay, so C part is mn plus lm plus nl. Okay, so first of all, I will write this NL here and LM on the third position. Now MN plus NL, it will be ML. So ML, ML plus LM. So your starting point, finish point, same point. So the answer will be 0 vector. So that was the question number 6. Okay, so we are going to the next question. Okay, so whenever these all are triangles, okay? So whenever you use triangles, so there are two ways in which these triangles are used. The triangle can be used to do the addition of the vectors. The triangle can also be used to do the subtraction of the vectors. Whenever you use the triangle to find out the sum of two vectors or addition of two vectors, uh, at the head of the first vector, you always put the tail of the second vector. We also call it head to tail rule. At the head of the first vector, you put the tail of the second vector, and then you join the tail of the first vector with the head of the last vector, and that is gives you your resultant. When you do subtraction by the help of the triangular method, the vectors, their tails are joined together. The vectors, their tails are joined together. And then we complete the triangle. And let me show you, for example, this first part, if I will increase the size so you can see it more clearly. Okay, so now look at this first part. So you can see P and Q, and we have to tell what does this mean. If you look at this triangle carefully, these two vectors, okay, P and Q, their tails are joined. And I told you whenever you make a triangle and you have put two vectors such a way that their tails are joined with each other, and that is subtraction. So then we look at that in the resultant, you have put arrows in which direction? Your arrows are towards the P, the head of the P. So this vector will represent P minus Q. So this will represent P minus Q. So this arrowhead, this resultant will represent P minus Q. Okay, go to the next one. Again, here you can see these two vectors P and Q, their tails are joined and triangle is completed. That represents a subtraction. If you put two vectors such a way that their tails are joined together, like here, their tails are joined, so and triangle is completed, so that means it's a subtraction. So then you see this is the resultant vector and its arrows are towards the head of the Q. So this will represent Q minus P. That will represent Q minus P. Here in the C, you can see the two vectors, A and B. You have put them such a way that their tails are joined together. So this is representing a subtraction. So in the C part, the A and the B, their tails are joined. So this is 100% subtraction. This is the resultant vector. Its arrows are towards the head of the B. So this represents B minus A. Okay, the D part here, at the head of the B, you have put the tail of the A. So this is addition. And you have joined the tail of the B with the head of the A. So this is addition. This is head to tail rule. This is addition by triangular law. So let me show you. At the head of the first vector, you have put the tail of the second vector. Then you have joined the tail of the first vector with the head of the last vector. That is addition. So this represents A plus B. Okay, the next one, the E part. Here again, you can see the tails of R and S are joined together and triangle is completed. This represents a subtraction. Okay, so that is subtraction. And when you look at the resultant vector, you have put the arrows towards the head of the S. So this subtraction is S minus R. Okay, this one. Here again, you can see at the head of the R, you have put the tail of the S and you have joined the tail of the R with the head of the S. So at the head of the first vector, you have put the tail of the second vector. Then you have joined the tail of the first vector with the head of the last vector. This is subtraction by the triangular law. This is, so I said subtraction. This is addition. This is 100% addition. And so this represents R plus S. Then the G part here again M, and then you have N, and this is this triangle is representing addition, but there's a problem. The resultant vector, the arrows are not from the tail of the first vector to the head of the last vector. They are in the opposite direction. So basically, this is representing M plus the negative of the M plus N. Let me show you. You see, this is the first vector. On the head of the first vector, you have put the tail of the second vector. So this will be addition. But the problem is the resultant is supposed to be from the tail of the first vector to the head of the last vector. But these arrows are in the opposite direction. So this is negative of the M plus N. This one is tricky. H part, here you can see both the vectors placed in such a way that the tails are joined together. Whenever you put two vectors in such a way that the tails are joined together, and you have completed the triangle, that represents a subtraction, and it means that it's a subtraction. Okay, now if you look at the resultant vector, its arrows are towards the head of the N, so this will represent N minus M. Okay, N minus M. So that was question number 7. It's H part. Okay, so now we are going to the next question. The next question is question number 8. He says simplify the following. So here 2 column vectors are given and you have to add them. So 5 and my x will be subtracted from the x, the y will be subtracted from the y. So 5 minus 3, it will give you 2. 4 minus 2, it will give you 2. So, and okay, so let's go to the next question. B part, minus 1, 3, minus 3, minus 4. Okay, so minus 1 minus 3, it will become minus 1 plus 3. So that will be 2. 3 minus 4, it will become 3 plus 4. That will be 7. Okay, so C part is here we have 3 column vectors. Okay, so we can do them. There's no problem. Okay, so 2 plus 5, 7. 7 minus 7 will be 0. 3 minus 2 will be 1. 1 plus 3 will be 4. I hope you understand this. The x, they are added with each other. The y's, they are added with, subtracted with each other. Now we have the D part of the question number 8 is 4, 7, minus 2, 5, minus 3, minus 6. So very simple. Okay, so 4, 7, minus 2, 5, minus 3, minus 6. So it will be 4 plus 2 will be 6. 6 minus 3 will be 3. 7 minus 5 will be 2. 2 plus 6 will be 8. So this is how you do it. And I think this is very simple. Okay, so now we are going to the next question. The next question is question number we have question number 9, and it says the diagram shows the vector A. If you look at the vector A, this is the tail of the vector A, this is the head of the vector A. So how much is this? 1, 2, 3, 4, 5. It has moved 5 steps on the x-axis and 1, 2, 3 and 3 steps on the y-axis. So I can write its column vector. And here you see 1, 2, 3, 4 steps it has moved on the x-axis, and 1, 2, and minus 2 steps on the y-axis. If you look at here, 1, this is minus 1 on the x-axis, 1, 2, 3, 4, 5, 6, minus 6 steps on the on your y-axis. So A can be represented with the column vector 5, 3, B can be represented with the column vector 4, minus 2, and the C can be represented with the minus 1, minus 6. Okay, so their first question is, he says, on a sheet of squared paper or graph paper, draw appropriate triangle to illustrate the following vector addition. So he wants me to add A plus B. Now A plus B, so if you want to use triangular law, and you want to find out the resultant of the A plus B, so very simple. I will start from anywhere. So for A, I will have to move 5, 3. Okay, so 1, 2. This is my starting point. 1, 2, 3, 4, 5. 1, 2, 3. This is my end point. So join them. That's the A vector. Then I will draw the B vector. That is 4 minus 2. 1, 2, 3, 4, 1, 2. So that will be 4 minus 2. So join the tail of the first vector with the head of the last vector, and that will be your a plus b. So this is how this a plus b is done. Then the question is find out the b plus a. You can start from anywhere. For example, I started from here. First of all, I will move the b, that's 4 minus 2. 1, 2, 3, 4, 1, 2. So that is the B. Join these 2 points. That will be the B. Then I will have to draw the A. The A is 5, 3. So 1, 2, at the head of the first vector, I will put the tail of the second one. So 1, 2, 3, 4, 5, 1, 2, 3. So this will be my vector A. I will join these 2 points. Then join the tail of the first vector with the head of the last vector. That will give you B plus A. Okay, so the next question they're asking is find the a plus c. Okay, so a is 5, 3 and the c is minus 1, minus 6. Okay, so minus 1, minus 6. Okay, first of all, I will draw 5a, 1, 2, 3, 4, 5, 1, 2, 3. So that is a. Then I will draw the c. It is minus 1 and minus 6. One step to the left, that's minus 1. And then minus 6 means go 6, 1, 2, 3, 4, 5, 6, 6 steps downward. So I will join these 2 points. So that will be the c vector. Join the tail of the first vector with the head of the last vector. That will represent a plus c. In the same way, they ask us to find out the b plus c. You see, start from anywhere. For example, I started from here. So 1, 2, 3, 4, 1, 2, 2 steps downward. So that is your B. One step to the left, 6 steps down. That is your C. Okay. So join the tail of the first vector with the head of the last vector, and that will represent the addition. That represents B plus C. So that was the question number 9. Let me reduce the size so you can see the whole solution together. So hopefully you can see on the screen, it's very small sized now, but I hope that you can see this. That is how you can do the question number 9. Okay, so we are going to the next question. The next question is PQRS is a quadrilateral. Simplify the following. So this quadrilateral is also important, PQRS. And when you join the diagonals intersect at the point P. Simplify the following. He says PT plus TR. PT plus TR. So the answer will be PR. Okay, so the answer will be PR. So the answer will be PT plus TR, it will be PR. Okay, the next question they ask us is the SQ plus QR. SQ plus QR, the resultant will be SR. Okay, so the SQ plus QR, where it ends, it starts. So it's good. SR will be the answer. Then he says TR plus ST. You see the TR plus ST. Okay, so you can change the order. You first write ST, TR plus ST. That will be ST plus TR, and that will be SR. Okay, SR. Then we have the SQ plus QR plus PS. Okay, so let me show you my. First of all, SQ plus QR, that will be SR. Then you have the plus PS. Change the order. Bring this PS first. PS plus SR, where it ends, this starts. So it will be PR. Okay. So then we have here RQ plus QT plus TP plus PS. Okay. So RQ plus QT, that will be the RT plus the TP plus the PS. So where it ends, it starts, okay, RT plus TP, that will be the RP plus PS. Where it ends, it starts, so it's good. So RP plus PS will be RS. So that is how you will do the question number 10 is done. So let me reduce the size so you can see the whole question together. So now on your screen, the question number 10 is showing up. And so that's question number 10. I hope you understand. Okay, so we are going to the next question here. He says the diagram shows three vectors A, B, and C, and on a sheet of squared paper or graph paper, use the triangle law of vector subtraction to illustrate a vector subtraction. Okay, whenever you want to subtract two vectors, you put them in such a way that the tails are joined with each other. So look at first of all A. This is the tail, this is the head. 1, 2, 3, 4, 5, 6, 7. 7 positive steps on the x-axis, then 1, 2, and 2 positive steps on the y-axis. That's the column vector for the A. For the B, it is 1, 2, 3, 3 on the x-axis, 1, 2, 3, 4, 5, minus 5 on the y-axis. 1, 2, 3, 3 positive on the x-axis, 1, 2, negative 2 on the y-axis. A is 7, 2, B is 3 minus 5, C is 3 minus 2. The first question is find A minus B. If you want to find out A minus B, the method is very simple. You put start from anywhere, and from that point, the tails of both the vectors to be subtracted, they should be there. The tails should be on the same point, okay? So for example, I started from here, so I will draw the A is 1, 2, 3, 4, 5, 6, 7, 2 steps up. This is the end. So join them, that's A. For B, I'll start from the same point for the B. 1, 2, 3, and 1, 2, 3, 4, 5. Negative 5 steps on the y-axis. So this is your B. Join these their heads with each other. And because we want A minus B, so the resultant, its arrows will be towards the head of the A. So this represents A minus B. That is the triangular law of the vector subtraction. Okay, in the same way, you want us to represent B minus A. So I will start from anywhere because I want to represent the subtraction. So both the vectors, you will make them such a way that the tails are joined with each other. So I will put a dot here. This is my starting point. So 1, 2, 3, 4, 5, 6, 7, 1, 2. So I will join these 2 points. That is the vector A. For vector B, 1, 2, 3, and 1, 2, 3, 4, 5, minus 5. So that will be the B vector. Join their heads. This is subtraction because you want B minus A. So the arrows of the resultant vector should be towards the head of the B. Then it will represent B minus A. Very simple, straightforward. Okay. Then they want us to find out A minus C. So what is the A? A is 7, 2, and C is 3 minus 2. Okay. So I will put them in such a way that their tails are joined 1, 2, 3, 4, 5, 6, 7, 1, 2. That is your vector A. From the same point, I will start drawing the C vector, which is 3 minus 2, 1, 2, 3, 1, 2. So this is your C vector. Join their heads. And because you want, this is subtraction, because you want A minus C, the arrows of the resultant should be towards the head of the A. That will represent A minus C. Then you have to represent C minus B. And for the C minus B, you can see I will draw the C. C is 1, 2, 3, 2 steps down. So this is the vector C. And the vector B is 1, 2, 3, and 1, 2, 3, 4, 5, minus 5 steps down. So this is join these points. This is your vector B. And then complete the triangle. And because I want to represent C minus B, so the arrowheads of the resultant vector should be towards the C, then it will represent C minus B. Whenever you do the subtraction by the triangular law, the two vectors to be subtracted, their tails are joined with each other. So this is how you will do this. Let me reduce the size so you can see the whole question together. So that is the question number 11, A, C and D part. And this is question number 11A and it's a B part. That's the A and B part. And this is C and the D part. Hopefully you understand how the, the triangular law of subtraction works. Okay, so here we go to the next question. The next question, he says the diagram shows a parallelogram ORTS where the OR, this OR is equals to small r, vector R, and the OS is equals to the vector S. It's a parallelogram. So remember in the parallelogram, the opposite sides are parallel and equal in length. So OR is represented with the R in the same way ST will also be represented with the R. OS is represented with the S, so the RT will also be represented with the S. If you will go opposite, for example, if you go from S to O, it will be minus S. If you go R to O, it will be minus R. If you go from T to R, it will be minus S. If you go from T to S, it will be minus R. In the parallelogram, the opposite sides, they are equal in length and so they are parallel to each other. So they, in the vectors, they have the same vectors. They represent the same vector. So he says express the following vectors in terms of the R and the S. So the first question is what is the RT? RT is equals to OS. So that will be S. So we are using this parallelogram. So the RT is question, the RT will be equals to OS and the RT will be equal to the vector S. Okay. Then their question is what is TS? TS will be equals to RO and that will be minus R. The TS is equals to RO, so TS is equals to minus R vector. Then their question is what is OT? If you want to find out OT, here you can see from O go to S, from S go to T. That is called bypass. Okay. If, for example, the question is OT, so for OT, I will go from O to R plus R to T. O to R plus R to T, that is bypass. O to R is R and R to T is S. So the OT represents R plus S. This is how you do the C part. Okay, next question is RS. They want us to find out RS. So from R, I will go to O. From O, I will go to S. This is called bypass, and very easily you can find RS is equals to RS. From R, go to O, and from O, go to S. From R to O is minus R, and this is plus S. So S minus R. In the same way, their question is what is SR? If you go SR, this is SO plus OR. That is the bypass. SR will be equals to SO plus OR. SO is minus S and OR is plus R. So SR represents R minus S. R minus S. Another thing is that in your mathematics, you might have studied that these are the two vectors and they are the adjacent sides of a parallelogram. So if you join O with the T, this is the point where the tails of the vectors were joined with the opposite corner of the parallelogram. This diagonal OT is equals to R plus S. This is called parallelogram law. So OT directly according to parallelogram law is also equals to R plus S. Okay, so we are going to the next question. He says simplify. Here we have simplify the following if possible. RS plus ST. Okay, so this will be RT. RS plus ST, it will be RT. Then question is RS minus RT. Okay, I will convert the negative. I will change when I will change the sign. RS minus RT, change the sign, this negative sign. So this order will change. This will become TR. So write the TR first, then the RS. So now it is good T to R from R to S. So the answer will be TS. Okay, next question is RT minus RS. So RT minus RS, so convert this sign, change this sign, so their order will change. This become SR. Okay, now write this first, this second. So SR plus RT will be equals to ST. So then we have the RS minus the D part. D part is RS minus ST. So RS minus ST and RS plus TS. So you see this ends at S, this starts at T. If I write it first, then it ends at S, it starts with R. So there is no possible answer, not possible. That was D part. Okay, now we are on the E part. He says RS minus TS. Okay, RS minus TS. So I will change this sign into positive, so their order will change. RS plus ST. This ends at S, it starts with the S, so it will be RT. Okay, F part. Here we have three terms, RS plus TR minus TU. R to S from T to R minus T to U. Okay. So TR, I will write this first, plus RS minus TU. This will become TS minus TU. So change the sign. So TS plus UT, write it first, UT plus TS. It ends at the T and this starts from the T, so it will be US. So that is how you do the question number 13, and I hope you understand. Here, question number 14, he says, find the value of the x and of the y in the following equations. So x will be added into the x and the y will be added into the x, and then we will compare both the sides, both the x values on both the sides. So we will be able to find out the value of the x. Okay, so here this will become x minus 3 upstairs and equals to 7. Downstairs you will have y plus 2 and equals to minus 5. So I will compare the x on both the sides. So x minus 3 is equals to 7. So x will be equals to 7 plus 3 and x will be equals to 10. In the same way, I will compare the y's here. Y plus 2 is equals to minus 5. So y will be equals to minus 5 plus 2 and the y will be equals to minus 3. So this is how you do question number 14A part. In the B part, we have this. Okay, so it will be 3 minus x and downstairs equals to minus 6 and y minus minus 8 equals to 9. So you will have 3 minus x equals to minus 6. So minus x will be equals to minus 6 minus 3. So minus x will be equals to minus 9. So minus minus will be gone. So x will be equals to 9. In the same way, y plus 8 is equals to 9. So y is equals to 9 minus 8. So y is equals to 1. So this is how you will do question number 14. It's B part. Question number 14, C part. Again, same process. Okay. So y minus 4, and then you have 3 plus 2x, and that will be equals to 6 by x. So I will do that, and you will have y minus 4, and downstairs you will have 3 plus 2x equals to 6 and x. So compare the y minus 4 equals to 6. So it will be y is equals to 6 plus 4 and y will be equals to 10. In the same way, 3 plus 2x is equals to x. So x will be equals to x minus 2x. So x will be equals to minus x. X will be equals to minus 3. Now we have question number 14 and it's the D part, and he says 2x 5 minus y minus 3 minus 10 equals to 4, 3y. Okay, so a little. So it will be 2x minus y plus 3. This negative will change the sign, okay? Downstairs you will have 5 plus 10 equals to 4, 3y. So compare these two, you will find the value of the y. So 2x minus y plus 3 equals to 4, 15 is equals to 3y. So first of all, I will find the value of the y. So it will be 15 equals to 3y. So y will be equals to 15 divided by 3, and that will be 5. Now we will compare these two terms with each other. So 2x minus y plus 3 is equals to 4. So 2x minus y is equals to 4 minus 3. So 2x minus y equals to 1. So 2x is equals to, we have the value of the y, so that is 5. So 2x minus 5 is equals to 1. So 2x equals to 1 plus 5. 2x equals to 6. So x will be equals to 6 divided by 2. And that will be 3. Question number 14 is D part. The diagram shows three vectors P, Q, and R. So I will note down their column vectors. So to make them again and again becomes easy. So it's 1, 2, 3, 4, 5, 6, 7, 7 to the right. And on the X, 1, 2, 3, 4, 5. Minus 5, we went down. Okay, so we can write the column vector of the P in the same way. On the x-axis 1, 2, 3, 3. On the y-axis does not move. So on the y-axis will be 0. So here 1, 2, 3, 4, 4. 1, 2, 3, 4, 5, 6, 7, 8. So here you can see P is 7 minus 5, Q is 3, 0, R is equals to minus 4 and 8. The first question they're asking is to, on the sheet of a squared paper on graph paper, draw appropriate parallelograms to illustrate the following vector addition. Okay, so that is the question. And so if you want to add P plus Q, so first of all, here you can see I have drawn the P, and so P is 1, 2, 3. I have added them with the, not with the parallelogram law. I have added them with the, you know, triangular law. So what I did, I draw the P, 7 minus 5, and then I draw the Q, which is 3, 0. Then I join the tail of the first vector with the head of the last vector. And that gave me this diagonal gives me the addition. Okay. So let me show you on the paint. Okay. So if you want to draw, so you will, how you will make on the, okay. So let me show you how this is done. Okay. So first of all, you will draw the P. Okay. This is the P. Then you will draw the Q. The Q will be such a way that it's the Q and the P, they are joined together like this. Okay. Then you will suppose that these are the sides of the parallelogram. Okay. If they are the sides of the parallelogram, then one Q will be here. Okay. Then you will join this point with this. So you will see this parallelogram will be completed. Then I will join where the tails were joined with the opposite corner. And that will be the resultant. Okay, whether you go with the triangular law or you go with that, you go with the parallelogram law, in both the cases, the result is same. Okay. So this is how you do that first part. Okay, so now we are on the question number 15. It's B part. Here you have to find out Q plus P with the help of the parallelogram law. So if you want to find out the P, Q plus P, first of all, I will draw the Q. Here you see, then I have drawn the P, then I have joined the tail of the Q with the head of the P. So that gives me P Q plus P, but this is this is by the triangular law. They has asked us to find the resultant with the help of the you know, by the parallelogram law. Okay, the method is very simple. You see, let me show you. And okay, so I'm going to do it with the, okay. First of all, I will draw the Q. Then I will draw, you see, the P. P is 1, 2, 3, 4. Okay, so it will be, so this is Q. I will make the Q and the P in such a way that their tails are joined. Then the same Q I will draw here, and the same P I will draw here. I know the column vectors of the P and the Q, so it's very simple. And I will complete this parallelogram. Now, for the resultant, what I will do, where the tails are joined, okay, here. Okay, so this red line represents the resultant. In the parallelogram where the tails were joined of the Q and the P, you join it with the opposite corner, and that will give you the resultant of the two vectors. Okay, so whether you use triangular law or you use the parallelogram law, in both the cases, the result will be the same. Okay, so this was uh, Q, and this was your P. So their tails were joined here. Here their tails were joined. So you completed the parallelogram, supposing that they are the adjacent sides of the parallelogram, and this is how you find their resultant. So I hope you understand this B part. And okay, so here you can see question number 15A. I have drawn Q, I have drawn P, I have drawn them in such a way that their tails are joined together, and then I suppose that they are the sides of the parallelogram. So like Q, I make a Q here. Then I join these 2 points. So parallelogram is completed. Then where the tails were joined together, I join that with the opposite corner, and that is the P plus Q. This is how you will add the P and Q with the help of the parallelogram law. Then they ask you to do the Q plus P. Okay, so Q plus P, that's the B part. I will draw the Q from the same point. I will draw the P, and okay. So the Q here, same Q I will draw here. And once this is done, I will join these 2 points. And once this is done, the parallelogram will be completed. Where the tails are joined, I will join it with the opposite corner. And that will be my result. So that will be Q plus P. This is how you will do this uh, with the parallelogram law method. Okay. The next one they're asking is the P plus R. Okay, P plus R. So I can show you the P plus R. You know the P is 7 minus 5 and the R is minus 4, 8. Okay. So I will draw first of all the P. I'm starting from here. I will draw the P. Then from the same point, I will draw the R. And the same R I will draw from this point. Then I will join these 2 points. This is a parallelogram completed. Where the tails are joined, I will join it with the opposite corner, and that will give me the P plus R. Okay, the next question is Q plus R. So if you want to find out Q plus R, so Q is 30, R is minus 4a. So I will draw the P, Q you can see here, 30 minus 48. This is R, the tails are joined. Then I will draw another R here from this point and join these 2 points. So the parallelogram will be completed. So we suppose that the Q and the R, they are the adjacent sides of a parallelogram. We complete the parallelogram. Then where the tails were joined of these two vectors, I join it with the opposite corner, and that give me the resultant. That give me Q plus R. So hopefully you understand. I have drawn them. You see, I did it with the help of the triangular law. And here I did the same. Let me show you. This is A part. So this is A part. So here the P plus Q is done with the help of the triangular law. And here the P plus Q is done with the parallelogram law. Okay. So here the Q plus P is done with the help of the triangular law. And here the Q plus P is done with the help of the parallelogram law. Here the C part, we have done the P plus R with the help of the triangular law. This is triangular law. And here, let me reduce the size. The P plus R is done with the help of the parallelogram law. Now, here you see here the Q plus R is done with the help of the triangular law. And here the Q plus R is done with the help of the parallelogram law. So you can find their addition by triangular law or by parallelogram law. It's up to you. But in the question, he asks us to do it with the parallelogram law. So that's important. So now we are on the question number 16. It says illustrate graphically the following vector sums using the vectors given in the diagram. So here you have R, here is the Q, here is P. So I will first of all try to find out the column vectors. So let me go to that is, okay. Now the R is 0, 7.5. The R is on the x-axis, you have not moved, only on the y-axis. So this is 0, 7.5. And the P is 5, minus 2.5. The P is 1, 2, 3, 4, 5, 1, 2, 2.5. So this is 5, 2.5. The Q is 7.55. 7.5. And on the y-axis, you have moved 5. So this is the column vectors of the P, the R, P, and the Q. Now, the first question, he asks us to find out the P plus Q. Okay, P plus Q. So I will start from here. I will draw the P. P is 5 minus 2.5. So this is P. On its head, I will start the tail of the Q. The Q is 7.55. Then I will join the tail of the first vector with the head of the last vector. And that will give me P plus Q. Okay. Then their question is find Q plus P. Okay. So first of all, I will draw the, start from here. I will draw Q. The Q is 7.55. So I will draw Q. Then at this point, I will draw the P. Then I will join the tail of the Q with the head of the P. That will give me Q plus P. If you look at them, see 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 12.5, 1, 2, 2.5, 12.5, 2.5. How much is this? 8, 9, 10, 11, 12, 12.5, 2.5. So the answer of the P plus Q and the Q plus P in both the cases is same. Let me reduce the size so you can see them together. So the answer of the P plus Q and the Q plus P is same. Okay, now next thing. He want me to find out the P plus Q, find their result, then add it with the R. Okay. See. So let me show you. So first of all, I will draw P, then I will draw Q. I will join this point with the head of the Q. That will give me P plus Q. Then I will add R. This is now the Q plus P plus Q. Here at this head, I will draw R. I will join the tail of the P plus Q with the head of the R. That will give me P plus Q plus R. So if you count it, this is the resultant. Okay. So let me reduce the size so you can see it more clearly. So hopefully you understand. First I added P and Q. I got their resultant. In that resultant, I added R. So now this is the resultant of the P plus Q plus R. Okay, the next part they are saying P plus, in the bracket I have Q plus R. So first of all, let me find out Q plus R. So I started from here. So this is Q and this is R. So their resultant is Q plus R. So here I've drawn a P such a way that its head should come here. Now this is Q plus R. Join the tail of the P with the head of the Q plus R. That will give you P plus QR. So let me show you. So now you can see more clearly. Let me wait. So this is how it is done. So if you count the final resultant here 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 12.5, and how much you go up? You went up 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Okay, this is you went 10 up. Okay, so let's count here. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. 10.5, I think, and when then you went up, how many steps? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So in both the cases, the final resultant of both these, whether you do P plus Q and then plus R, or you do Q plus R and then add it into the P, in both the cases, the answer is same. And that is the next question. He says, is the P plus Q and the Q plus P same? Yes. And is the P plus Q plus R and the P plus Q plus R is same? Yes. And why? Because in both the cases, the column vector of the final resultant was same. Hopefully you understand this little tricky thing. So question number, the next question coming up on your screen is question number 17. He says PQRS is a parallelogram. O is the point of intersection of its diagonals. Okay, so it's a parallelogram, so which means the PS, the QR, they are same. PQ and the SR, they are exactly same. Okay, so PQ plus PS, PQ plus PS. So what will be their resultant? So they are the adjacent sides of the parallelogram. So their resultant will be this diagonal PR. This is parallelogram law. PQ plus P plus PS. That will be PR according to the parallelogram law. PR is their resultant. Okay. So let me show you. This answer, the answer here, PR, this is by the parallelogram law, and we are using this diagram. PQ plus PS will be this diagonal. diagonal of the parallelogram. So, okay, so the next question is RO minus QO. So, okay, we will change that sign. So RO minus QO, RO plus OQ. When you change the sign, the order will change. So the R to O and from O to Q. So this will be RQ. Very simple. Okay, next thing they are asking is PR minus SR plus SQ. Okay, so PR minus SR plus SQ, PR, change this sign, so their order will change. So PR plus RS plus SQ. So it will become PS and plus SQ, so it will become PQ. Simple, straightforward. Okay, then he says the PQ is A, so this is represented with the A, and PS is represented with the B. He says find in terms of the SR. SR will be equals to the PQ, so that will be A. So he says, what is the SR? SR is equals to PQ, so that will SR will be equals to A. Okay, then he says PR. PR is this PR is the sum of the A and B. This is parallelogram law. So PR, or you also come with the bypass. If you want to find out PR, I can go from P to Q, Q to R. Okay. If you want to find the PR is equals to P to Q, Q to R. P to Q is A and the Q to R is B. Q to R will be equals to PS and that will be B. Okay, simple. And the next question is SQ. SQ. From S go to P, from P go to Q. When you go from S to P, that will be minus B. So SQ will be equals to SP plus PQ. SP is minus B plus A, so it will be A minus B. So this is how you will do the this part. So let me reduce the size so you can see the whole part together. So this is question number, I think this is question number 17. Hopefully you understand. Okay, so we are going to the next question. It's a kite. In the figure show below, the diagonals of the PQRS intersects at the K. Find for each of the following equations the vector which can replace U. So it's a kite basically. Okay, he said it's a kite. So it looks like a kite. He did not say a kite. Okay, SQ plus SK plus U equals to 0. SK plus U is equals to 0. Okay, so let me show you. Okay, SK plus U, so U will be equals to minus SK. So when you convert this sign into positive, this order will change. So U will be equals to KS. Then this is SP plus PQ plus U equals to 0. SP plus PQ plus U equals 0. SP plus PQ, that is SQ, and plus U equals 0. This SQ will go on the other side and it will subtract there. So U will be equals to minus SQ. So when you convert this sign, and the order will change, and so U will be equals to QS. Okay. Next is PS plus SK plus KR equals to U. Okay. So PS plus SK plus KR equals to U. So PS plus SK, that will be PK plus KR equals to U. So PK plus KR, that will be PR equals to. So U will be PR. Okay, then they say PK plus, and in the bracket I have minus SK plus equals to U. So PK plus, this will become minus SK equals to U. So PK, when this negative will become positive, the order will change. And so it will have PK plus KS equals to U. So it will become PS equals to U. Okay. Then they say PS plus minus RS equals to U. Okay. So PS minus RS equals U. So when this will become positive, their order will change. PS plus SR equals to U. So this will become PR. So PR is equals to U. So F part is PQ plus QR plus and minus PR. Okay. So equals to U. So PQ plus QR, that will be PR, and this minus PR equals to U. So PR, convert this sign and their order will change. So PR plus RP equals to U, switch starting point, finish point is same point. So the resultant will be the zero vector. So this is how you will do this exercise. So my dear students, the exercise is completed. This was exercise 7. This was exercise 7B from the book D4, New Syllabus Mathematics 7th edition. And this was about the vectors. This is the third exercise we have done. And hopefully you have understood. If you find this video interesting, useful to you, please like this video. Also share the link of this video onto your Twitter accounts, on onto your Facebook and onto your Instagram. That will help me promote my channel. It's a great blessing for me that I can make these videos. So thank you very much, everyone. Have a good day. God bless you all.